Ever wondered what JavaBeans are and why they are so important in Java programming? Well, JavaBeans is a component architecture for Java. It's like a set of rules or conventions that provide a standard way to create reusable software components. Now, these software components are not just any components, they are the ones that encapsulate multiple objects into a single entity, which we call a bean. The beauty of JavaBeans is that they are portable and reusable across different applications. This means that you can create a bean once and then use it in multiple places, making your code more efficient and easier to manage. To give you a better idea, think of a JavaBean as a capsule. Inside this capsule, you have different objects, each with its own characteristics and behaviors, but on the outside, it's just one single entity. This encapsulation simplifies software development, as it allows you to manage complex systems by dealing with manageable units. But what's more interesting about JavaBeans is that they are not just about encapsulation, they are also about creating simple and consistent objects. Every JavaBean follows a set of conventions, making them predictable and easy to use. For instance, every JavaBean has properties, methods, and events that follow specific naming conventions. These conventions make JavaBeans a powerful tool in the Java ecosystem. They provide a standard way to create objects, making your code easier to understand and maintain. And because JavaBeans are so predictable, they can be used in various contexts, from simple standalone applications to complex enterprise systems. JavaBeans are like the building blocks of Java programming. They are small, simple, and reusable pieces of code that you can use to build larger and more complex systems. They are like the Lego blocks of software development, providing a simple and consistent way to create complex structures. So, in a nutshell, JavaBeans are all about creating simple and consistent objects that can be used and reused in various contexts. They are the foundation upon which many Java applications are built, and understanding them is crucial for any Java developer. But remember, like any tool, JavaBeans are not a silver bullet. They are just one piece of the Java programming puzzle. To become a proficient Java developer, you need to understand and master many other concepts and tools. But JavaBeans are a great place to start. But what makes a JavaBean a JavaBean? Let's dive into their defining characteristics. First up, encapsulation and properties. JavaBeans encapsulate their fields, also known as properties. They provide public getter and setter methods to access and modify these fields. These properties are typically private, restricting direct access to the underlying data, which is a major boost to encapsulation. Next, the default constructor. JavaBeans must have a public no-argument constructor. This requirement allows JavaBeans to be easily instantiated and used in various contexts, such as in frameworks or tools that create objects dynamically. Serializability is another key characteristic. JavaBeans frequently implement the Java.io serializable interface, enabling them to be serialized, that is, converted into a stream of bytes and deserialized. This is vital for saving the state, persisting objects, or transferring them over a network. Then we have the Java naming conventions. JavaBeans follow standard naming conventions for their getter and setter methods. Getters typically use the prefix get, followed by the property name, like getName, while setters use the prefix set, like setName string name. For Boolean properties, getters may use is instead of get, like isAvailable. Lastly, JavaBeans support event handling. They can fire events and handle event listeners, which is useful for building interactive components with a simple event-driven architecture. Each of these characteristics plays a crucial role in defining what a JavaBean is. They encapsulate properties, making it easier to maintain code. The default constructor allows them to be used in various contexts. Serializability enables them to be saved, persisted, or transferred. The naming conventions make the code more readable and easier to understand. And the support for event handling allows JavaBeans to be interactive, responding to user actions or system events. These characteristics make JavaBeans flexible, reusable, and easily identifiable in your code. You may be asking yourself, where do we use these JavaBeans? Well, the answer is, in a variety of places. JavaBeans are an integral part of Java development, serving multiple purposes. One of the key applications of JavaBeans is in creating reusable components. JavaBeans encapsulate multiple objects into a single object, the bean, making them portable and reusable across different applications. By reducing the need for redundant code, JavaBeans promote code reuse, making your programming more efficient and streamlined. Moving on to a more advanced application, we have Enterprise JavaBeans, also known as EJB. EJB is a server-side component architecture built on top of JavaBeans. It gives JavaBeans additional capabilities for enterprise applications. These capabilities include transaction management, remote method invocation, and dependency injection. So, if you're developing an enterprise-scale application, EJB can be a powerful tool in your arsenal. JavaBeans are also extensively used in various Java frameworks and tools. Have you ever heard of Java Server Faces, or JSF for short? In JSF, JavaBeans represent managed beans, playing a crucial role in the framework's functionality. Similarly, if you've worked with Spring, you would have encountered JavaBeans serving as components in the Spring inversion of control, or IOC container. This usage in frameworks and tools further emphasizes the versatility of JavaBeans. Now you might be wondering why all this emphasis on JavaBeans? It's simple. JavaBeans provide a way to create simple, consistent objects with specific properties, methods, and events. They follow a standardized convention, making them easy to understand and work with, especially for new developers. Plus, their wide support in the Java ecosystem allows them to integrate with various frameworks and tools, making them a vital part of Java programming. As you can see, JavaBeans are widely used across the Java ecosystem, making them a crucial part of Java programming. Whether you're building a small-scale application or an enterprise-level system, JavaBeans can simplify your work and increase your efficiency. So the next time you're working on a Java project, remember the humble JavaBean and the power it holds. Now that we know what JavaBeans are, let's look at a real-world example. Today we'll create a simple JavaBean representing a person. This will help us understand the structure and functionality of a JavaBean. So, let's start by creating a new class named Person. This class will have private properties, namely name and age. Remember, properties in a JavaBean are typically private to ensure encapsulation. Now we need to provide public getter and setter methods to access and modify these properties. For the name property, we'll have getName and setName methods. Similarly, for the age property, we'll have getAge and setAge methods. Notice the naming convention here. Getter methods use the prefix get followed by the property name, while setter methods use the prefix set. Next, we need a no-argument constructor. This is the default constructor that allows our person JavaBean to be easily instantiated. So we'll add a public person constructor that doesn't take any arguments. Also, to make our person JavaBean serializable, we'll have it implement the java.io serializable interface. This will allow our JavaBean to be converted into a stream of bytes, which is useful for saving the state of the object, persisting it, or transferring it over a network. And there we have it, a simple JavaBean representing a person. It encapsulates the properties name and age, provides getter and setter methods for these properties, has a no-argument constructor, and implements the serializable interface. This JavaBean can now be used in various contexts. For instance, it can be a part of a larger application, be stored in a database, transferred over a network, or even used as a template to create more complex JavaBeans. This example gives us a clear picture of how a JavaBean is structured and how it operates. As you can see, JavaBeans are simple yet powerful tools in the Java ecosystem. They promote reusability and consistency, and their standardized conventions make them easy to understand and work with. So what are the pros and cons of using JavaBeans in our projects? Let's delve into this, starting with the advantages. Firstly, we have consistency. JavaBeans follow a standardized set of conventions. This means that irrespective of who wrote the bean or what project it's used in, we can expect the same structure and behavior. This makes it easier for developers to understand and work with them, fostering a smoother development process. Next up is reusability. Beans can be used across different projects and components. This reduces duplication and saves time. Instead of writing code from scratch, developers can utilize existing beans. You can think of it as a write once, use anywhere approach. It's not only efficient but also promotes a cleaner, more organized code base. Then we have integration. JavaBeans are widely supported in the Java ecosystem and can be used with various frameworks and tools. This wide applicability makes them versatile and flexible. Whether it's server-side programming with enterprise JavaBeans, or using them in frameworks like Java Server Faces and Spring, JavaBeans seamlessly integrate and perform. Now, let's touch on some potential disadvantages. Some developers argue that the necessity for a no-argument constructor can sometimes lead to the creation of objects in an improper state. Also, the verbose nature of JavaBeans, with their getters and setters, can lead to a lot of boilerplate code. However, modern IDEs automate this process, mitigating this issue to an extent. Lastly, JavaBeans are mutable by nature, meaning their state can be changed after creation. In certain scenarios, especially in a multi-threaded environment, this can lead to issues. However, with careful design and synchronization, these issues can be managed. Despite any potential drawbacks, the benefits of using JavaBeans in Java programming are significant, making them a key tool in a developer's toolkit.